Yo, what's good, guys? Today we're gonna be doing separation of variables. Um, this stuff is generally not that terrible. It's otherwise known as the Fourier method. Obviously, however you pronounce that, Fourier method. Um, it's used to solve differential equations. Where there's two things like an x and a y being multiplied or divided. Um, yeah, that's pretty much it. It's basically just algebra and then integration and then you're done. That's really it. It's algebra, integration, and then whether or not you need to find a particular solution, then it's plugging in a point and finding your c value. That's all it is. So let's get started. So first thing you want to do to doing separation of variables is you want to move your dx's and your dy's over to two different sides. So I usually keep my dx's on the right side, just because I think that x is like y equals mx plus b, mx and all that is on the right side, and y is generally always on the left, alone, just because that's how you read an equation, left to right. Um, so yeah, just gonna push this over to the other side, so you get dy is equal to 10x dx. Now, if you know this kind of looks like an integral, so that we can solve easily. So it's like how can we integrate this, uh, and get an integral that we know, and get rid of this dx. Well, I mean, we can just integrate both sides essentially. If you know, like that's kind of how things work in algebra. It's like if you multiply one side by two, you got to multiply the other. Same thing goes with integrals. So the integral of dy is just y. It's implied that there's like a 1 here, and that becomes y when you integrate it. So yeah. So y equals, and then integral of 10x is just 5x squared. That's pretty obvious. And then plus c. You always put the plus c on your x side. I'm pretty sure that um, most professors wouldn't be like, whatever, you didn't put it on the right side. It doesn't really matter. But you know, I put it on the right side because it's easier to solve, in my opinion, when you have to solve for it, and I feel like it just belongs on the right side with your x's, because it's like slope intercept in a way. I don't, yeah. Put it on your right side, if you want to. I think it looks nicer. Okay, so now we're doing this. This has a particular solution, is what it's asking for. It's asking for it at this point. So when we get to that, I'll basically explain how you do that. It's really not that terrible, and we've done it like multiple times. Basically, whenever you do a tangent line, like in basic derivatives, finding a tangent line, it's the same idea. So once again, you want to get your y. This time we have a y as well on the side with the x's. So we're gonna have to move that over there, and then a dx over here. So let's just do that. dy equals y over x plus x times x plus 1 dx. And then since y is in the numerator, we have to divide it. So it's 1 over y dy, or dy over y if you want to write it like that, equals uh, 1 over x plus 1, x times x plus 1 dx. So same idea, like we did it before. Once we get all the y's and dy's and the x's and dx's on one side, we just integrate both sides. So the integral of 1 over y dy equals integral of 1 over x times x plus 1 dx. So this integral is pretty easy. This is just ln of y, obviously. This, on the other hand, um, looking at this, u substitution doesn't work. Um, you know, because you're just gonna u substitute x for x. That doesn't really tell you anything. Um, So yeah, that'll just rephrase the problem, but in terms of use, that won't do anything. Integration by parts is obviously not going to work. So you do notice that it's 1 over two things. So you're going to want to use partial fractal decomposition in this case. A pro tip kind of about partial fractal decomposition, like how do I make two, like things that are even, if that makes sense. Like how do I make sure, like if this was like an x squared or like an x to the fifth, how do I make it so that it's like right? How do I split that into two things essentially is what I'm saying. In this case at least, when it's x to the first minus one, you can just think of this as a binomial, as x to the zero times x plus one. Because like obviously we should know how to do like x minus 2 times x plus 3 and split this obviously. This because it's just two binomials and just one, it's just a over this and b over this or whatever or vice versa. It's not too terrible. But when it's like you can just think of this and just yeah, it's the same idea because the x minus 0 is the same as just x. So, yeah. Okay. And then this is going to yeah, and then that this is true. A over x plus b over x plus 1 equals 1 is what we want to find. So obviously with partial fractal, it's a over x plus 1 plus bx equals 1. And what we want to do is just find x values that cancel out one of these terms, either the a term or the b term. I just did that vice versa. So x equals 0 will cancel out this b term here. So when x is 0, it's a equals 1. This is our a term. You see I just canceled out this b term and then I just plugged in 0 over here and I got a times 1 equals 1, which just means a equals 1. Okay? So doing the same for x, for a, to cancel out this a term and make this whole thing a times x plus 1 equal to 0, x has to equal negative 1. And negative b equals 1 means that b equals negative 1. I just drew like a chemistry beta or something, or like physics or something. Okay. So now we can just plug back up into this thing. Should have put the double in. I mean, it's technically the same thing, but it looks nice, and it's gonna be what we have to how we solve this problem. So just taking down this ln of y, this equals integral of 1 over x dx plus oh no, it's not gonna be there. It's not an integral. Plus negative 1 over x plus 1 dx. Okay, so these, once again, are pretty simple integrals. In fact, this integral is the same as the y one. So ln of x minus, because there's a minus in here, ln of x plus 1. Because the derivative of this is just going to be positive 1, so to make it minus, we have to minus the entire thing, plus c. Okay, this is a general solution. This would be right if it was asking like if it didn't give us a point basically, and didn't ask and didn't say particular solution. But since this problem it says particular solution, uh, basically just particular, or I just shortened it. But it'll say like give a particular solution for when y of 1 equals 3. So you obviously, if you know like this is just f of x equals 3. So x equals 1, y equals 3. Okay, I'm just going to write that point down here so we know. Okay, so just start plugging in. 3 equals ln of 1 minus ln of 2 plus c. Now, knowing ln of 1, that's an identity practically. Any log or ln of 1 is always 0. Just because anything to the 0th power is always 1. Any number. So what you're going to want to do here is set this entire thing equal to c. So we're going to do ln of 3 plus ln of 2 equals c. And there are two different ways that you could go about solving this at this point. If it's multiple choice and you just like don't know log rules at the time, you could just plug this into a calculator and you have a calculator provided, or you just know ln of 3 or ln of 2, but you somehow don't know log rule. So You just plug this into a calculator, and then assuming that the multiple choice it might be given to you in a log form, um, you could just just plug all the logs in your calculator until you find the one that has the same decimal. Um, or alternatively, you could use a log rule and just get the right answer, which is when two logs with the same base are being added, you basically you can just multiply the inside portions. So you get log of 6 equals c. So this is your c value, not your answer. Your answer, you just plug this in for c. So ln of y equals ln of x minus ln of x plus 1 plus ln of 6. This is your answer. Um, so yeah. If it was a free response, in this type of question, I would highly suspect that they would give you your answer as this with all logs and not as a decimal, not having c as a decimal, just because they're clearly like pushing logarithms in this problem. In case you haven't realized. um, So yeah, they're not. I highly doubt that they would put a decimal here. So if you didn't know this rule, you would literally just have to plug these into your calculator, find the decimal, or find the log that it was equal to out of this, knowing what your c value, looking at the c values of the given formulas of the given answers, and then finding which of those c values equals ln of 3 plus ln of 2. If you didn't know that how to do the log rule and get ln of 6, if you didn't know that. Um, so yeah, this is your answer. Separation of variables. It's not really that hard. It's just can you keep it in your mind during an exam uh, and not forget about it and know that when to use it, because you can't use this to like do like integrals or like you cannot use this to do like an integral problem really. It's only differential equations. So if you can keep that in mind, you should be good. It's one of those things. It's like the continuity or like limits. If you know the rules to them, it's just like you get free. You'll get a 100 no matter what. If it like you'll get all those questions right no matter what. That's pretty much how this is. Unless you make like a sign error or something like that, it's pretty much guaranteed because the integrals are really so simple, and like the extra work from a particular solution is really straightforward. So, I mean, I hope that helped you. I hope you learned a little bit something about partial fractal decomposition and then uh, how to like how to do separation of variables in general, just the order that you have to do it in. So, thanks for watching, my guys.